Welcome back to this tutorial series on building the classic card game Solitaire with Phaser 3. Previously in part 4, we went ahead and worked on adding in our actual logic for moving our cards around our various stacks in our game. If you missed the previous videos, there'll be links in the video description to the source code up to this point, as well as the complete source code for this video. There'll also be a link to the previous videos if you'd like to catch up, so let's get started. Alright, so now we have our core logic in place for handling our player input in our game. Now we need to go ahead and start building out our core Solitaire library that we'll be using for having our actual logic for our game. And then what we're going to do is we'll go ahead and tie that to our game scene and finish up our additional methods. And so to get started with building our core logic, what we're going to do first is we're going to go ahead and work on creating our types and our data models to represent our actual deck of cards. And so in the game of Solitaire, we're going to use a standard deck of 52 cards. We're just going to have the following attributes. A single card, we're going to have two colors, be red and black. There's going to be 4 card suits. We're going to have our spades, our clubs, diamonds, and hearts. And all the cards that are hearts or diamonds are the color red. All of the cards that are spades or clubs will be the color black. For each suit of cards, we're going to have 13 cards. We're going to have the ace, which will be number 1, well, the numbers 2 through 10. Finally, we'll have a jack, queen, and king, which is going to represent 11 for the jack, 12 for queen, 13 for king. And so each card will either be in one of 2 states. It's either going to be face up or face down. And so when a card is face down, we're going to show the player the back of our card frame, and the player's not going to be able to drag those cards around our scene. If the card is face up, then we're going to show the correct card frame, and the player will be able to drag those cards around as long as that card is not in our foundation pile. So to get started with modeling our deck of cards, the first thing we're going to do is let's make a new file in our lib folder. And so what we're going to do is we're going to make a new file. We're going to call it common.ts. And so what we're going to do is first let's go ahead and define our card suits. So let's do export const. We'll do card suit. And so for our suits, we'll have our 4 suits. So we'll have hearts, diamond, spade, and then we'll have a club. Now for each of our values on our object, we'll go ahead and have the same value. And then for our object, we'll do as const. So let's go ahead and add our type for our card suit. So we'll do export type, card suit will be equal to key of, type of, card suit. And so next we'll go ahead and add a type for our card values. And so instead of just doing a number, we're actually going to restrict this to the range of numbers that we know we support. So we'll do export type, we'll do card value. And so this is going to be 1 through 13. So we'll do 1 or 2 or 3. And we'll repeat this until we get to 13. Next, we want to go ahead and do our suit color. So I'm just going to copy these lines of code here. I'm going to go ahead and paste it. And so we're going to have our card, suit, and then color. And so we'll have black and red. So let's update our values. And let's go ahead and update our type. And so we're going to have card suit color will be the key of type of card suit color. Alright, so the last thing we're going to add to our file is we're just going to add a mapping between our card suits to the appropriate card color. And so we're going to store this on objects. We'll do export const, and we'll do card suit to color, so they equal to an object. And so now we want to do each of our various card suits. And so I'm just going to copy this here. We're going to paste it. Now for our card suits, we're going to have this be dynamic based on this here. And so I'm just going to copy this. We'll do card suit.heart, card suit.diamond, card suit.spade, and card suit.club. And so for our keys to be dynamic like this, we need to go ahead and wrap them in brackets. So then that way we can reference our variables to create the appropriate key. So now for our colors, let's go ahead and do our card suit color, and we'll go ahead and do red for our heart and diamond. So let's just copy this. We'll go ahead and paste it. And now we're going to do black for our other 2 suits. Then let's do as const, so then we can't modify our object. Alright, so the next thing we're going to do is we're going to create a class to actually represent our card instance. And so on our card, we're going to have 3 primary properties, and it's going to be our suit, our value, and if the card's face up or not. And then what we'll end up doing is we'll have our deck of cards consist of multiple instances of our card object. And so what we'll do is let's make a new file, and we're just going to call this card.ts. Let's export out our class. We're going to call it card. We're going to have 3 properties. Let's do suit. So this is going to be our card suit type. We're going to have value. So this will be our card value type. Then finally, we're going to have face up. And this is going to be a Boolean. Let's go ahead and add our constructor. So when we create an instance of our card, we'll need these values. And so we'll have suit. We'll have value. That'll be our card value type. And then finally, we'll have is face up. And we're going to add a default value of this. We'll set equal to false so we can pass this in. So now let's go ahead and update our private properties to have the correct values. We'll do this is face up. We'll do this face up is equal to is face up. The suit will be equal to suit. This value will be equal to value. And so on our card, we're going to go ahead and add some getters. We can actually return these properties. So we'll do get. Let's go ahead and do suit. We'll return a card suit. And so we're going to return this suit. And we'll want to do the same thing for value and is face up. So I'm just going to copy this. We'll paste it twice. And so we're going to have value. And we'll do is face up. And let's go ahead and update our types. And update our references. So we'll return this value. And we'll return face up. Two other things we're going to do is we're going to go ahead and add a getter to return our color for our card. And then we want to go ahead and add a public method to allow us to flip our card over. So let's go ahead and set face up equal to the opposite value. So let's do get color. For this, we're going to return our card suit color. And we're just going to return, we'll use that object we created, our card suit to color. And we'll pass in our suit for our key. That we return our color. And now let's do public. We'll do flip. So for this method, we won't take any arguments and we won't return anything. And we'll go ahead and do this. Face up will be equal to the opposite of what it's currently set to. So now that we have our object that represent our cards, next thing we do is we need to create a class to represent our full deck of cards. And so for our full deck of cards, we're going to need the following functionality. We'll need to be able to create our deck, which will consist of 52 unique cards, 13 cards in each suit. So for our deck of cards, we'll need to have a discard pile and a draw pile. We'll need to have the ability to draw a card from our draw pile. And finally, we need to be able to shuffle our deck of cards and re-add the cards from our discard pile back into our draw pile. And so basically, we're just modeling what an actual deck of cards is and how we can actually interact with it. So to go ahead and do this, let's make a new file, and we're going to call this deck.ts. Let's export out our class. And so now for our deck, we'll need an array to keep track of our cards that make up the deck. And we'll need arrays to keep track of our draw and discard piles. So first let's do cards. So for our cards, this will be a card array for our type. Next we'll have our draw pile. This will also be a card array. And then we'll have our discard pile, which will also be a card array. So now let's go ahead and create our constructor. So when we create an instance of our deck, we'll go ahead and set our cards to be an empty array, and we'll do the same thing for our draw and discard piles. I'm just going to copy this, paste it twice. So our draw pile will be an empty array, discard pile will be an empty array. All right, so then what we want to do is now we actually want to construct our deck of cards. And so to go ahead and do this, we're going to store this in a new method that we can use for be able to reset our deck. So what we'll do is we'll make a new method, and we're just going to call it reset. And we'll go ahead and call that. So let's add our public method. So we'll have reset. And we won't return anything for this. And so when we reset our deck of cards, what we'll want to do is we'll want to go ahead and reset our discard pile to be empty again. We'll want to have our draw pile have all of our cards in it. And then we'll want to go ahead and shuffle it. So what we're going to go ahead and do is let's go ahead and update our discard pile to be empty. To put all of our cards into our draw pile, we'll go ahead and do this. We'll do our draw pile will be equal to, and we're just going to go ahead and copy the objects from our other array. And so we're just going to go ahead and copy this .cards. Now we want to go ahead and shuffle. And so to go ahead and do this, we'll make a method to have this logic. So let's go ahead and add our public method. So we'll have public, we'll have shuffle. And so on this method, we won't return anything. And then for actually shuffling our cards, what we'll do is we're going to create a utils file that'll have this functionality. And so what we're going to do is we're going to call a function to do this. We're just going to call it shuffle array, and we'll pass in our draw pile that we want to go ahead and shuffle. And so we'll come back and add this function in a second. We're going to focus on finish defining our deck of cards. All right, so on our deck of cards, we're going to need a way to go ahead and grab what cards are tied to our deck and which cards are tied to our draw and discard piles. So what we'll do is we'll create 3 getters. So let's do get cards. This is going to return an array of cards. And so we'll return this in our cards property. Let's copy this. We'll paste it twice. And so let's go ahead and do our draw pile. And we'll update our reference. And then we'll do our discard pile, and we'll update our reference. So besides these 2 public methods, we'll also need a way to draw our cards. So let's go ahead and do public, we'll do draw, and so this will return a card instance or undefined if there's no cards we can draw. And so what we'll do is we'll return this, we'll reference our draw pile, and we'll call the shift method to go ahead and remove that element from our array.
All right, so one other public method we're going to need is we'll need a way to shuffle in our discard pile. And so for our discard pile, we just want to take all of the cards from our discard pile and go ahead and add those back into our draw pile. And so what we'll do is do public, we'll do shuffle in discard pile. This method won't actually return anything. And so to do this, we're going to reference our discard pile. We're going to use the for each method to iterate through each card. And so for each card, we want to go ahead and flip this back over to, so that way it's face down. And so we'll do card.flip. And then what we'll do is we'll add these to our draw pile. So we do this draw pile, we'll do push, and we'll add our cards back in. Finally, we'll go ahead and make sure our discard pile is now empty. And so we'll go ahead and set it equal to an empty array instance. All right, so now we have our public methods and our getters. Now we actually need to go ahead and create our deck. So for creating our deck, we need to go ahead and create new card instances for each of our card suits and for each of our values. So to do this, let's make a new private method, and we're going to do create deck, and we'll do void. And so we're going to call this method from our constructor right before we do our reset. And so we'll do call this.createDeck. So now inside here, what we want to do is we need to go ahead and create our 52 card instances. And so to do that, we're going to grab all of our values from our card suits. And then for each of those suits, we'll create our card instances. So to do that, we're just going to do object.values to grab all the values from one of our objects. And we'll use our card suit object. And now that this will return an array of those values. And so now we can use for each. And so for each of our strings, our card suits, we want to go ahead and create our 13 card instances. And so for this, we'll do an inner loop. So we'll do for let I equal 1. I is less than 14. Then we want to go ahead and increment I. And so for each iteration, we want to go ahead and use that as our value. And so we'll do this.cards and we'll do push. And so we'll create a new card instance. And so we'll pass in our suit. We'll pass in I as card value. All right, so now that takes care of modeling our cards. And the last thing we need to do is now we need to actually define our shuffle array. So what we're going to go ahead and do is let's make a new file. And we're going to call this utils.ts. And let's go ahead and export out a function. And we're going to call this shuffle array. All right, so when we shuffle our array, we won't actually return anything. We're going to do an in-place shuffle. And so to do this, we'll need one argument. It's going to be the array that we want to go ahead and shuffle. And so for this, it's going to be some type of array. And so instead of typing it as any, we're going to use T, and we'll go ahead and provide that. So what that's going to allow us to do is when we call shuffle array, whatever type we provide, we'll be able to use that. All right, so for actually shuffling our cards, what we're going to do is we're going to use a common algorithm called the Fisher-Yates shuffle. And so this is a common algorithm that allows us to do a shuffle in place. And so it's really efficient, and basically at a high level how it works, what we're going to do is we're going to iterate through our array in reverse, and basically we're going to move elements in our array around based on a random value. And so this is actually really easy to code, and so what we're going to end up doing for our code is now we just need to iterate through our array, calculate a random value, and basically just move our elements around. So what we're going to do is we're going to do a for loop. We'll do let I equal our array.length. And then what we'll do is we want to subtract 1, so we have our 0-based index. If I is greater than 0, we want to go ahead and decrement this. So that way we're going through our array in reverse. So now we need to go ahead and calculate our random value. So let's just do const j will be equal to math.floor. And we're going to do math.random. And so we're going to times that by I. So now we have our random value, and now we need to store a reference to our element in our array. So we're going to make a new variable to do that. We'll do const temp be equal to our array, our I index. And now we just need to swap those two around. And so we'll do array I is going to be equal to array j. And now we'll do array j is going to be equal to temp. So basically all we're doing is we're just looping through our array in reverse, and then whatever this index is, the last element at that time, we're going to go ahead and store that in a temporary value, so then that way we have a reference to it. And now we're just going to update our references in our array to swap our values. So now we can do back in our deck class. So what we can do in our method is let's go ahead and update our function so we can update our import. All right, so one last thing we need to do before we jump into our Solitaire class is we're going to create a class to model one of our foundation piles. And so for our foundation piles, we'll need to have the ability to support the following functionality. We'll need properties to keep track of what card suit is assigned to that pile and what the current value of that pile is. And then we'll also want to have methods to go ahead and reset the initial value and to add new cards to the foundation pile. So to do this, let's make a new file, and we're going to call this foundation pile.ts. Let's export our class, export class, foundation pile. And so now for our properties, we'll have our suit, which will be a card suit, and then we'll have our current value. And so for this, we want to go ahead and have it be our card value or the value 0 when we first create an instance of our foundation pile. So let's go ahead and add in our constructor. And so we'll do, for our arguments, we'll expect a suit, which will be our card suit. So we'll go ahead and do this. Our suit will be equal to the suit, and we'll have this current value be equal to 0. So now we'll go ahead and add some getters for these two properties. So we'll do get suit. We'll return this dot suit, and now we'll do get value. So we'll go ahead and return our card value or 0. So we'll return this current value. So now we want to go ahead and add our two public methods, and so we'll do public reset. This won't return anything. And so for this, we'll just go ahead and update our current value to be 0. Now for adding a card, do public, add card. We won't have any arguments, we'll return void. And so now what we're going to want to do is we want to go ahead and increment our current value. And if we're already at our max, so 13, we won't actually do anything. So we'll add a safeguard, do if our current value is already equal to 13, we'll go ahead and return. If it's not equal to 13, then let's go ahead and increment it by 1. And so this is going to simulate if we add a card to our foundation pile, it'd be like the next card would be showing up there. So now with our foundation pile class created, that actually wraps up our classes and our models and types that we're going to use to represent our deck of cards and other types we need for the game Solitaire. So now we're going to go ahead and switch back to our Solitaire class, and we'll start adding in our actual functionality for our various methods that we defined before.
So for our Solitaire class, the first thing we're going to do is we're going to create some new private properties to go ahead and track some of the piles we'll need for our game. And so we'll need to keep track of our deck of cards, our 4 foundation piles, and then our tableau piles that are used in our game. And so to go ahead and do this, let's go to the top of our class. First, let's go ahead and add in our deck. And so for our type, we'll have our deck. Next, we'll have our 4 foundation piles. And so we'll have foundation, and then we'll do pile, and we'll do spade. For our type, it'll be foundation pile. I'm going to go ahead and copy that, and we're going to do this 3 more times. One for each of our different suits. So then we'll have clubs, hearts, and then we're going to have diamonds. Then next, we're going to go ahead and create our tableau piles, and for this is just going to be an array of arrays, and then I'll have a type of card. And so we'll have our tableau piles, and it'll be card array. So now what we'll do is go ahead and add in our constructor, and we'll go ahead and initialize these. And so start with our deck, so we'll set equal to a new instance of our deck class. Then we'll go ahead and do our foundation piles, and so we'll have our club foundation pile be equal to a new foundation pile. And so for this, we'll have our card suit, so we'll reference our object, and so we'll do card suit, and we'll do clubs. I'm going to copy this line, and we'll add our other piles. Then we'll have spades, hearts, and then diamonds. Let's update our various suits. So we'll have spades, heart, and then diamond. So now for our tableau piles, what we'll do is we'll just sum this equal to an array that has 7 empty arrays. Alright, so next we'll need to reference these from our game scene. So what we'll do is we'll add a couple getters to go ahead and grab these various piles. And so we'll have get, we'll have our draw pile. Alright, so we'll go ahead and return this. We'll reference our deck, and we'll reference our draw pile. So I'm going to go ahead and copy this, and we're going to do our discard pile and then our tableau piles. And then we'll also do our foundation piles. So we'll change this to discard pile, update our reference. Now for our tableau piles. And so for this, will be an array of arrays. So we'll update our reference. And then we're going to have our foundation piles. And so for our foundation piles, let's go ahead and update our return type. It'll be an array of foundation piles. And so we'll go ahead and return. All right, so inside here, we'll go ahead and return our various foundation piles. So we'll go ahead and start with spades. Let's go ahead and do clubs, followed by hearts, and then we'll have diamonds. All right, so one other getter we're going to add is we're going to add a getter to checking to see if our game is actually won. And so what we'll do is we'll get, and we'll do one game. This is going to return a Boolean value. So to actually check to see if our game is won, what we'll do is we'll check each of our foundation piles just to make sure their value is set to 13. And if it is, that means the player's placed all of the cards, ace through king, in the various foundation piles. And so we'll go ahead and do return, and we're going to do this. We'll do our foundation pile club, we'll do our value, will be equal to 13, and we'll do our other foundation piles. So now that we have our properties and our getters that we'll need for our class, we're going to start working on adding our logic for the methods that we previously added. And so we're going to go ahead and start with our new game method. And so for our new game method, it's going to be responsible for setting up all of our card piles in our game. And so to go ahead and do this, what we'll do is we're going to go ahead and reset our game state so that all of our card piles are empty. And that way we can go ahead and start new games if we want. And then we're going to go ahead and shuffle our deck of cards. Once we do this, we'll deal out our cards to our 7 tableau piles, and that way will match what we have laid out in our game scene. So our first card pile will have 1 card, second pile will have 2, 3, 4, and so on, up until we have our 7 card piles. So go ahead and do this. What we'll do is first let's go ahead and work on resetting our deck, and then we'll go ahead and reset all of our other piles. And so what we'll do is we'll reference our deck, we'll use our built-in reset method that we added. Next, for our tableau piles, we're just going to reset this back to an empty array. And so what I'm going to do is I'm going to come up to our constructor. I'm just going to copy this here. Now we want to go ahead and reset our 4 foundation piles. And so what I'm going to do is I'm just going to copy this here. Go ahead and paste it. And then we'll go ahead and change this to reset. I'm going to copy this and also add that to each of our piles. All right, so next we just need to go ahead and fill out our tableau piles. And so for this, we'll use logic that is very similar to how we built these piles in our game scene. And so what we'll do is we'll do a for loop, and then we'll have an inner for loop for filling out the piles. So we'll do for let I equals 0, I is less than 7, I plus equals 1. So I'm just going to copy this. We'll go ahead and paste it, and we'll go ahead and change this to be j. So we'll do it for, we're going to let j equal I. If j is less than 7, then we're going to go ahead and increment it. So now what we'll do is we'll grab an instance of our card by drawing it from our deck. So we'll do const card will be equal to this, our deck. We're going to do draw, and we're going to go ahead and type this as a card because our deck should be full of cards. And now what we're going to go ahead and do is if this is the last card in our stack, we want to make sure we go ahead and flip it over. And so if j is equal to I, then we go ahead and flip our card. Now we want to go ahead and add these cards to our tableau piles. And so we'll do our tableau piles. And so for our index, we're going to go ahead and use our j index, and we're going to go ahead and do push. We'll push our card. All right, so next for our draw card method, when we draw a new card from our draw pile, basically what we want to do is we want to flip this card over and add it to the top of our discard pile. If we're not able to actually draw a card because our pile is empty, we'll go ahead and just return false since we're not able to draw a card. So to go ahead and do this, what I'm going to go ahead and do is I'm going to copy this here, where we go ahead and try to draw our card. I'm going to paste it. What I'm going to do is I'm going to get rid of our type, and because it can be undefined now. And so if our card is actually undefined, we're going to go ahead and return false. If our card's not undefined, then what we want to do is we want to go ahead and flip it over. So we'll call our flip method on that card. And now we want to add it to our discard pile. So we'll go ahead and reference our deck, our discard pile. And we want to go ahead and push that card to that array. Then we'll go ahead and return true since we're able to draw a card. All right, so for our shuffle discard pile logic, the first thing we're going to do is we're actually going to make sure our draw pile is actually empty. If it's not empty, we'll return false, and we're not able to actually shuffle our deck yet. If it is empty, then we're going to go ahead and call that method on our deck instance. So what we'll go ahead and do is we're just going to add a safety guard. So we'll do if our deck, our draw pile, if our length does not equal 0, so we have cards remaining, we'll go ahead and return false. Otherwise, we'll go ahead and return true. And before we do that, we'll just reference our deck, and we'll call our shuffle in discard pile. And so what that's going to do is going to simulate us taking our discard pile, flipping it over, so we start drawing cards again. All right, so next up, we're going to focus on our 2 methods for being able to play our discard cards. And so when we play our discard cards, there's going to be 2 possible moves. We're either going to play a card to our foundation pile or to our tableau pile. And the first thing we'll want to do is we want to make sure that the card that was played is actually valid. And if so, we want to add that card instance to that appropriate location in our Solitaire class. And so for this changes, we're going to focus on our play discard pile to foundation first. And so when we play a card from our discard pile to our foundation pile, we're going to want to do the following things. First, we want to go ahead and get a reference to the top card in our discard pile. And so what we'll go ahead and do is let's throw that in a variable. Do const, we'll do card will be equal to our deck. And we want to go ahead and reference our discard pile. And now we need to grab the top card. So what we'll do is we're going to use the length of our discard pile. We'll go ahead and subtract 1. And And that should give us the top card. And so if that card doesn't actually exist, so if our discard pile is empty, we want to go ahead and return false. And so if our card is undefined, we'll go ahead and return false. All right, so if our card's not undefined, the next thing we want to do is we want to check the appropriate foundation pile and make sure that this is the next card in that sequence. And so as an example, if I'm playing the 4 of spades to the foundation pile, I want to go ahead and check our foundation pile spade property and make sure that the current value is 3. And if it's not 3, we'll go ahead and return false. All right, so to go ahead and do this, we'll make a new private method. And so what we'll do is we'll do if not this is valid move to add card to foundation. And so for our method, we'll need to pass in the card that we're checking. We'll want to go ahead and return false. So now what we'll do is let's go ahead and add this method. And so we'll come to the bottom of our class, we'll add in our private method. And so we'll have our card, and it'll be, for our type, it'll be card. And this is going to return a Boolean value. And so what we're going to want to do is first, we want to go ahead and grab the relevant foundation pile. And so for this, we'll go ahead and use a switch statement. So we'll do let foundation pile. We'll type that to our foundation pile. Next, we'll go ahead and do a switch, and we're going to do our card suit. So now what we're going to want to do is we want to go through our 4 different card suits and then update our foundation pile to have the correct reference. And so we'll have case, let's do our card suit, and we'll go ahead and start with our clubs. And so if our card suit is clubs, then our foundation pile is going to be equal to our foundation pile club, and we can go ahead and break out of our switch statement. So then what I'm going to go ahead and do is we're going to go ahead and add our other piles. So I'm going to copy this, we'll go ahead and paste. So after clubs, we're going to go ahead and have spades. Then we'll have hearts followed by diamonds. Now let's update our references. And so we'll have our foundation pile spades, foundation pile hearts, and then foundation pile diamonds. And then we'll go ahead and add in our default case. And so for now, we're just going to go ahead and do break. So now that we have a reference to our foundation pile, we just want to go ahead and check to see if the current card value is equal to our foundation pile plus 1. So we're going to do return card.value is equal to our foundation pile.value plus 1. All right, so now let's go ahead and jump back up to our method. All right, so if our card move is valid, then what we'll want to do is we'll actually want to move that card instance to that pile, and then we want to go ahead and remove it from our discard pile. And so to go ahead and do this, we're going to go ahead and make a new private method for adding the card to our foundation. And so we'll do this, and we'll do add card to foundation. And for our method, we'll need to go ahead and pass in our card instance. And now to remove it from our discard pile, we're going to reference our deck, our discard pile, and we'll do pop to go ahead and remove that from our array. And then we'll go ahead and return true since it was a valid move. So now let's go ahead and add in this method. So what we'll do is come to the bottom of our class, go ahead and add in our method. Our card will be card. And so for this method, we won't return anything, so we'll just do void. So now what we want to do here is we just want to call the add card method on the relevant foundation pile. So what I'm going to go ahead and do is I'm just going to copy this code here. We're going to go ahead and paste it. And now we want to go ahead and for the relevant foundation pile, we call add card. All right, so real quick, one of the things you might notice is in our IntelliSense, we currently have an issue with our foundation piles. And what it's reporting is it's being used before it's actually assigned. And what's happening is in our code, because we're using our switch statement, we start off with our foundation pile being set to undefined. And if we ever reach our default statement here, then our variable will never be assigned, and now we're trying to access a property on it. And that's going to throw an error in our code, and that's not something we want. And so to protect against this, we need a way in our code to make sure that we cover all of our cases inside our switch statement and for TypeScript to be aware of that. And so one way to do this is we can create a utility function that will make sure for whatever string we're trying to parse here, we cover all of our various edge cases. And if we ever reach this utility function, then we'll throw an error, and then that way we'd handle that elsewhere in our code. And ideally, we should never reach this util function that we add. And so to go ahead and do this, let's jump into our util files real quick. And so what we're going to do is let's export our new function, and we're going to call this exhaustive guard. And so for this function, we're going to take one argument, and we're just going to call this value, and for the type, we'll set it equal to never. And for our return type, we'll also do never, and we'll come back to this in 1 second. And so all we're going to do in this function is we're just going to throw a new error. And so for this, we're just going to say error reach forbidden guard function with unexpected value. And so for our value, we're just going to go ahead and stringify whatever that value is. All right, so what we're doing here is basically we're just telling the TypeScript compiler that no argument should ever be passed to this function, and this function should never return a value. And so all it's going to be used for is for when we compile our TypeScript, it's going to ensure that we cover all of our bases here on our switch statement. And then that way we can avoid errors like this. And so to make use of our function, what we do is we get rid of our default break statement, and we replace this with our exhaustive guard, and now we pass in the same value that we used up here in our switch statement. And so what's going to happen is this is going to resolve the issue we had in our IntelliSense. And the reason for that is now we're covering all of our possible values for our card suit. And the reason for that is we have this currently typed to these 4 values, and we're covering them in our 4 cases. If this was just a regular string, so like if I type this as a string, then what's going to happen is now we don't have all of our edge cases covered because we don't have a default value here or any other case to handle these. But because it is static, because it is strictly typed to those 4 values, we do have it covered. And so as an example, if I get rid of our diamond suit here, we also have the same issue because diamond could end up reaching our exhaustive guard. And so now our code won't actually compile and we need to handle it before we're able to run our code. And so this is just another safeguard that we can add to our code to be a little more defensive while we're programming. And so what I'm going to do is I'm going to copy that. And I'm also going to replace our default statement up here with our exhaustive guard. All right, so next up, we'll have our play discard pile to tableau method. And so what we're going to want to do is when we play a card from our discard pile to our tableau, the first thing we want to do is we want to make sure that we actually have a card in our discard pile. And so what I'm going to do is I'm going to copy this logic here. We grab a reference to that card and we'll go ahead and paste that. And so next, what we'll need to do is we'll need to grab a reference to our target tableau pile. And so to go ahead and do this, let's make a new variable. We'll do const, we'll do target tableau pile. We're going to set that equal to this, our tableau piles, and then we'll have our target tableau pile index. And so now we're just going to add a safeguard. So if this pile doesn't exist, so if it's undefined, we'll go ahead and just return early. If our target tableau pile is undefined, we'll go ahead and return false. And now what we want to do is if we do have that pile, now we want to make sure it's a valid move for adding a card to our tableau. And so for this, what we want to do is we want to make sure it's the next card in our sequence. And so as an example, let's say if our tableau pile has the 5 of diamonds and we're trying to play the 4 of spades or 4 of clubs. And so for the next card, this would be valid because it has to be the opposite color and it has to be the next value when we're counting down. And so to do this check, we're also going to add this to a private method because we'll be using that similar logic for our other methods. And so what we'll do is we'll add our checks. We'll do if not this, and so we'll add a private method and we'll do is valid move to add card to tableau. And so for this method, we'll need to go ahead and pass in the card we're trying to add and our target tableau pile. And so if it's not valid, we want to go ahead and return false. If it is a valid move, now we want to go ahead and add this card from the discard pile to the target tableau pile. And so what we'll do is first we'll start with our tableau piles. We'll do our target tableau pile index. Now we want to do push to go ahead and add in our card. And now from our discard pile, we can go ahead and remove it. So we'll reference our deck, our discard pile. Now we'll go ahead and call the pop method to go ahead and remove it. So now we need to go ahead and add in our new methods. Let's come to the bottom of our class. Let's go ahead and add in our private method. So for our card, we'll have our card type. And then for our tableau pile, this will be a card array. And now we want to go ahead and return a Boolean value. So now to actually do our checks, we need to grab a reference to the last card in our stack of cards in our tableau. So then that way we can make sure the card we're playing is the opposite color and it's the next card value that we expect. So to do that, let's add a new variable, do const last tableau card. We're going to set it equal to our tableau pile. And we'll go ahead and use our tableau pile length to grab our last card. So we'll go ahead and subtract 1. All right, so now what we'll do is we'll go ahead and compare the color on our 2 cards, and if they're the same, we're going to go ahead and return false. And so we'll do if our last tableau pile card color is equal to our card color, we want to go ahead and return false. All right, so next we'll want to check our card values. So what we'll do is we'll do if our last tableau tile card, our value does not equal our card.value plus 1, then we'll go ahead and return false. And so in our example, if we're playing the 4 of clubs, then our card's value will be 4 and our last tableau card value will be 5. And if we add 1 to it, since they're not, if they are equal, it'll be true, otherwise it'll be false. All right, so if it is valid, then we're going to go ahead and return true. And so before we move on, we're going to want to cover a couple edge cases. So the first one we want to cover is if our tableau pile is empty. So if we're trying to add a card to a stack where there's no cards currently, the only card that can go here will be a king. Any other value is not a valid move, and we want to show that. So to do this check, we're just going to reference our length on our tableau pile. And so if our length is equal to 0, then we can only accept a king. And so to do that, we're just going to do our card value. And so if our card value is equal to 13, then it would be a valid move. If it's not equal to 13, it'd be invalid. The other check we want to go ahead and add is if our last card in our pile, if it's already an ace, no other cards can be added on top of it. And so what we're going to go ahead and do is we're just going to add a safeguard so we can return early. So after we grab our last tableau card, so we'll do if our last tableau card dot value is equal to 1, then we'll go ahead and return false because we can't add any additional cards. All right, so now we wrapped up our logic for our discard pile cards. Now we're going to go ahead and add in our logic for moving our tableau pile cards around. And so for moving our cards, we have two cases. The first one is if we want to move a card from one pile to another, and then if we want to move a card to our foundation pile. And so what we're going to want to do is for both these checks, the first one we want to do is make sure that we actually have a card in that tableau pile. And if not, we'll go ahead and just return early. If we do have a card, then we need to make sure that's the next valid card in that sequence. And so what we're going to do is we're going to start with moving our tableau card to our foundation pile. And so what we'll do is let's go into our method here. So move tableau card to foundation. Let's go ahead and make sure we actually have a card in our tableau pile. So what we'll do is let's grab a reference to that tableau pile first. And so what we're going to end up doing is we're going to do logic similar to what we did up here, where we grab our target tableau pile and we make sure it actually exists. Let's just copy that block of code. We'll go ahead and paste it. And we'll go ahead and change this to tableau pile index. And we'll go ahead and just change this to tableau pile. So once we have our tableau pile, we want to go ahead and grab a reference to the card. So the last card in our stack. And we want to make sure that actually exists as well. And so what I'm going to go ahead and do is I'm just going to copy this code here. We grab a reference to our card and we'll go ahead and paste that below it. And so instead of referencing from our deck and our discard pile, we want to grab it from that tableau pile. And so we'll do our tableau pile. We want to grab our tableau pile length and grab the last card. And so if the card's undefined, we'll go ahead and just return early. So now what we want to do is we want to make sure this is a valid move for adding this card to our foundation. So a very similar logic that we did up here, and when we played our discard pile to our foundation, we want to do this here. So we'll copy this block of code. Let's go ahead and paste it. And so if it is a valid move, we want to go ahead and add this card to our foundation and remove it from our tableau pile from our array. And so what we're going to do is let's just copy this code here and we'll go ahead and paste it. And so we'll add our card to our foundation, but instead of remove it from our discard pile, we just want to go ahead and remove it from the tableau pile that we're currently referencing. All right, so next up, we have our move tableau cards to another tableau pile. All right, so in our method, the first thing we want to do is we want to go ahead and grab the provided tableau pile index and the card index. We want to make sure that card is actually faced up to the player. So when our game starts, only the bottom card in our tableau pile stacks is actually visible. And so if I try grabbing a card that's below it, that's face down, we shouldn't actually be able to move it around. And so if our card's not face up, we'll go ahead and just return early. So go ahead and start adding that check. The first thing we want to do is we need to grab a reference to our various tableau piles, and we'll go ahead and store our reference to those. And so what we'll do first, we'll do initial tableau pile. We'll set equal to this, our tableau piles, and we'll use our initial tableau pile index. Then we want to go ahead and grab our target tableau pile. We'll set that equal to our tableau piles, and we'll use our target tableau pile index. And now we want to do is make sure both of these exist. So if neither of them exist, we'll go ahead and just return early. So if our initial tableau pile is undefined or our target tableau pile is undefined, we'll go ahead and just return false. All right, so next we need to go ahead and grab a reference to the card that we're trying to move. And so to do that, we'll store that in a variable. Do const card is going to be equal our initial tableau pile. And we'll go ahead and use our card index that was provided. And so if our card is undefined, so if we provide an invalid card index, we'll go ahead and just do return false. And so if our card does exist, now we add that check to make sure it's face up. So if our card is not face up, then we'll go ahead and return false. As if our card is face up, next we want to make sure it's actually a valid move. And so what we'll do is let's come up to our method where we added our discard pile to our tableau. Let's copy this block of code here. And what we'll do is we'll go ahead and paste it here. And so what we're gonna do is a valid move to add card to tableau. So we'll have our card and our target and then our target tableau pile. So finally, all right, so then finally, if the move is valid, now we need to actually move our cards from one pile to another. And so if we grab just the bottom card, we're only going to move one card over. If we grab an index where there's more cards on top of it, we need to move all of those cards from that array, from that spot to the next array. And so to go ahead and do this, we're going to go ahead and splice our array to grab the cards we need to move. So let's make a new variable, do const, we'll do cards to move. We're going to set it equal to our initial tableau pile. And so from this array, we'll use our splice method, and we'll go ahead and provide our card index of the card we want to move. So what this is going to do is going to go ahead and remove all cards starting at that point from our array and store it in a new array. So now what we can do is from our cards to move array, for each of our cards in this array, we'll go ahead and add them to our target tableau pile. And so we'll use our push method to go ahead and add in those cards. All right, so for our last method, our flip top tableau card method, what we want to go ahead and do is we want to go ahead and flip over the last card in our stack from our tableau pile once we remove the last visible card. And so as an example, if I take this card here and move it over, what we want to go ahead and do is flip this card here so the player can start using it. And so to go ahead and do that, what we need to do is whatever tableau pile index we provide, we just want to grab the last card in that stack, and if it's not face up, we want to go ahead and call our flip method on our card. And so what we're going to go ahead and do is let's grab a reference to our tableau pile first. And so what I'm going to do is I'm going to come up here to copy a little bit of our code. So I'm going to copy this here. We grab a reference to our tableau pile and a reference to our card. We'll go ahead and paste that in our method. So the first thing we're doing is we're grabbing our tableau pile based on the index. If it doesn't exist, we have our safeguard. Same thing with our card. So if there's no cards in there, we'll go ahead and just return early. And so if we do have a card, now we want to check to see if it's face up. So if our card is currently faced up, we don't need to do anything, and so we'll just do return false. If the card is not face up, now we want to go ahead and call our flip method, so then we flip it over, and we'll go ahead and return true because we did flip a card. All right, so those last changes, that actually wraps up our core logic for our Solitaire class. All right, with that brings this video to an end. In our next video, we'll continue working on our Solitaire game. So as a reminder, there's a link in the description of the video to complete source code for this video. And as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video in the series is released. For more great Phaser 3 content, please see the links on your screen now.